Welcome to the Fast Mode podcast series. I'm Tara Neil, and with me today is Douglas Kirkpatrick, CTO of Eridan. Eridan is a rapidly growing 5G startup based in Sunnyvale, California, that is reimagining wireless transmission to expand accessibility and improve the performance of every connected device in the world. Its Miracle transceiver is based on a patent-protected switching architecture that decreases the amount of power required to transmit a gigabit of data by 5 to 10 times. Doug is a VC and former chief scientist at DARPA, where he led projects ranging from rapid DNA synthesis to real-time holographic displays. Prior to DARPA, he was the VP of R&D for fusion lighting, and prior to that, a staff scientist and VP at SAIC. Doug joins us today as part of our exclusive editorial segment on Open RAN. Welcome, Doug. Great to have you on the show.
It's a pleasure to be here. Thank you for having me.
Okay, great. All right, so let's dive in with our questions today. So our first question is that let's see, what is the state of Open RAN adoption today? And what are some of the challenges faced by operators in achieving complete interoperability?
So the state of Open RAN today is, I would call it in a transition state. I think you're starting to see some of the large operators begin to experiment with Open RAN as a means to give themselves more flexibility. If you look instead at a different part of the market, if you look at the part of the market that is enterprise 5G or private wireless 5G, their Open RAN, and particularly in the middle part of that market as opposed to the very large customers pieces, that's very rapidly moving towards Open RAN. And that's moving towards Open RAN because for those smaller applications where you're talking about something that's the size of a small village or small town, you're talking about something that's maybe a mining facility or a timbering facility or an agricultural facility, the cost of an Open RAN system is substantially less than the cost of a single vendor conventional legacy system. It's just massively different. And the reason that it's happening there first is because those businesses are very sensitive to the return on investment. And their function is to look for things where they can get a return on capital which is going to be in the vicinity of something less than 24 months, ideally less than 18 months. And legacy systems are just not priced that way. Whereas if you look at an Open RAN system and you look at some of the Open RAN hardware structures that are becoming available, like Eridan, you're looking at ROIs that can be down in that range for those small systems. So the payback is almost immediate, and it becomes a business proposition like buying a PC. The PC payback periods typically are measured in 2 to 3 years. And that's very low risk. You move up the risk scale, they want the payback period to be a little bit shorter. It's just good business sense that's causing it to happen.
Mm-hmm. So the adoption will be much stronger in networks that that handle a smaller traffic volume and maybe a smaller user base. So are you saying that that's a good place to start?
Yeah, it's a great place to start. I think the things that Open RAN doesn't have as a standard at this point in time are how it tracks user payments and how it tracks multiple zones going from the East Coast of the United States to the West Coast of the United States, for instance, or where it's tracking customers that have 99.99% uptime requirements, and that if something goes down and they have to reboot it once a week, it's not a huge hairy deal. So when you look at those types of markets, it's very much like if you go back to the very early days of the personal computer. When I was just starting my graduate studies in the early 80s, everybody was on mainframe computers. And we looked at these things called PCs like toys. When was the last time you saw a mainframe computer? exactly this. And the reason you had mainframe computers is because they had massive uptime benefits. And sure, the PC might work, but you might have to reboot it twice a day. For a business proposition, that was unacceptable. But over the span of 10 years, even less, those PCs became the dominant workhorse of the entire industry. Why? Because now you can scale in a much more granular way. You don't have to make a $10 million purchase in order to have a computer system. That exact same thing is happening in the telecommunications world. That's exactly what ORAN brings.
So once we see a lot more adoption among the smaller players, would that have an impact to the adoption rates among the bigger players? Would that influence them?
Absolutely. In fact, the bigger players, I'll get in trouble, so I won't use any names. The bigger players are doing experiments looking like smaller players. So all of the bigger players have friends in the smaller players, and even in the smaller players. And they all have their own private wireless business. T-Mobile has a very strong private wireless business, as do Verizon, as does AT&T, as do many of the European and Asian operators. And they are doing experimentation with these open RAN systems in those smaller environments where they can learn from them themselves. It's a very, very active, chaotic environment right now as everybody's trying to figure out as rapidly as they can what works, what doesn't work, and how do they drive this towards the outcome that everybody's looking for, which is a more affordable way to grow connectivity.
Interesting. Okay, so can you tell us more about Eridan's Miracle module? How does it increase spectral efficiency?
It increases spectral efficiency through two ways. First and foremost, the signal coming out of the radio is dramatically more accurate than legacy systems. And so what that means is that where a legacy radio may be challenged to put 8 bits per hertz per second signals out, so-called 256 QAM, 2 to the 8th is 256 data states. The Miracle Radio has already demonstrated 64K QAM, 16 data states. Now, we don't do that in a 5G. 5G doesn't have that capability yet. 5G came out with 1024 QAM, which is the 10-bit state. We did that in a few hours. So the bottom line is that the ultra-clean radio allows you to put more, the ultra-clean radio signal, to be more specific, allows you to be more accurate, incorporate higher order modulations, and put more data in the same breadth of frequency spectrum. The second way that it gives you greater spectral usage is that that ultra clean signal leaving the antenna stays clean over the field of regard of the antenna. So if we have a small installation on top of our roof here in Sunnyvale. And as we walk away from the antenna, we maintain, and it's set up to go to a maximum of 8 bits right now to be able to use 8-bit commercial handsets as the testing protocol. As we walk away, we stay at 8 bits, 8 bits, 8 bits, 8 bits, 8 bits until we get to the end, and then we drop off because it's the end of our envelope. If we were doing that with a legacy system, we'd be at 8 bits, very close to the radio, and then we'd go to 6 bits, and then we'd go to 4 bits, and then we'd go to 2 bits. And the average over the entire footprint of the cell would be somewhere around 4 bits. So even within just the standard configuration, the clean signal allows you to get maximum data throughput over the entire footprint of the cell. So that dramatically improves spectral efficiency for the aggregate network. Does that make sense?
Yep, absolutely. So how does that translate into the user experience?
The user experience is that you're getting excellent throughput over the entire footprint of the cell, wherever you are. And from a private wireless perspective, the radio is tiny. It's about the size of your Wi-Fi router, and it goes up on a very small antenna. which allows you for some of these applications in agriculture where people want to have portable antennas or where they want to put it up in a very inconspicuous way. And you walk 250 meters from our building, you can't even tell there's an antenna there. It's that small. So it's one of those kinds of things that when people start to understand how flexible and prolific these things can be, it's going to be like a structured Wi-Fi experience with 10 times the range and 10 times the effective electrical efficiency for that range. Because you probably know that standard Wi-Fi has difficulty having a range which is significantly greater than about 50 meters.
Okay, so say in a scenario where an operator rapidly increases a subscriber base and you have this solution, would the Miracle module be able to cater to that rapid growth in in usage?
Sure. That is exactly one of the applications that the big MNOs are looking at as one of the reasons we were successful in winning one of the large projects from the NTIA, is to go forward with the next stage in the development of the Miracle technology, and that's to move forward with what we call the 4T4R 100 megahertz radio, which will be the next evolution beyond the first product, which we're now releasing. That allows a network to do what they call densification. If you go to the neighborhood that I live in the center of San Francisco, the average radius of a cell in San Francisco, a 5G cell, is about 600 meters. And literally every 1,200 meters, so 600 meter radius, another 600 meter radius, you have cells. You'll see another small trash can sized antenna and a box down at the bottom that's powering that. That's what they're doing for densification today. Those systems today pull about 160 watts each. Our system pulls 40 and it's on a path down to 30. So from an energy perspective, it's cheaper for them. As I just explained to you, we give them that cell throughput over the entire spectrum, over the entire footprint of the cell, excuse me. And so what you look at is that for an operator that's trying to densify, that's exactly how they'll use this. The large, long-range cells that we see out on the highway where you're driving at 65 miles an hour, those are going to continue to be the big, large-scale macro cells that you're used to seeing up on the 200-foot towers. But the densification in the neighborhoods where people are walking on foot, in shopping centers, things along those lines, that's all going to be heading towards this highly densified network in a very elegant fashion that you or I will be using our phones and we will not even stop to think about where our connectivity is coming from. It'll just be there.
Great. That's really interesting. So for operators, what kind or what level of energy savings can they expect, from the implementations?
In a brownfield network where we're going into existing deployments like my neighborhood in San Francisco that I mentioned earlier, they can look to see something there that's of order a 5-fold decrease in energy. Minimum energy savings will be somewhere around 2-fold if they're going into a brownfield configuration. If they're going into a greenfield configuration, and by that I mean they're going into a deployment where they're putting in new systems to cover new areas to densify a new domain, the energy savings can be 10-fold or higher. And that's because how you think about deploying this type of radio needs to take into account the flexibility of the network laydown that you use behind it. So there's a lot of ways that they can choose to save energy. There's trade-offs. They may, instead of saving maximum energy, they may choose to save half of the energy they could save and get a 5-fold reduction, but get a 2-fold spectrum benefit in terms of what the throughput they can get over their footprint. And it's a balancing act that all of the network operators will self-optimize around in terms of what they see in terms of their trade-off between capacity requirements and energy cost.
Brilliant. So, I think we understand a lot more about, Eridan's solution in this area. So let's shift the discussion back to Open RAN. What advantages does Open RAN bring to startups like Eridan?
It means we don't have to build the whole freaking network. I realize that sounds so trite, and I apologize for laughing, but if you think about the cost impact of having to go out and have an entire network, as opposed to being able to go in and say, I can do this little piece for you. It is a much, much easier way. If you think about the ecosystem for the personal computer or the ecosystem for your phone, and somebody writing an app that runs on your phone, or somebody coming up with a new, back when we used CDs, back with a new CD reader that they could put in, and I'm going to go from a CD to a Blu-ray to a DVD. Each of those, you didn't need to go buy a brand new computer. You just went and bought a new module. You swapped out the old module, you put in the new module, and up you went. That is what Open RAN means for the innovation economy. We can go faster. And as a consequence of that, those of us that are in the innovation economy, Open RAN is a boon because it allows us to bring our technology to the customer without having to do the entire soup to nuts. It's not perfect. Please don't get me wrong. Open RAN has got a lot of warts and a lot of pimples, and it's got a lot of things that make it very difficult to use from an engineering perspective. But it's a hell of a lot better than not having it.
Okay. Amazing. I think, those insights are really helpful for us to understand, not just the challenges that, and also a lot of other factors that operators have to consider in moving on with Open RAN, and also in exploring new technologies and solutions. I think, we have come to the end of the session today. Thank you, Doug, for joining us and for sharing your insights on these topics and also Eridan's role in this space. Do you have anything else to add on?
Thank you for having me, and we hope to see you in your neighborhood someday in the near future.
Great. Yep, excited. Okay, to everyone else, thank you for tuning in. If you want to learn more, visit www.eridan.io and follow us for more updates and insights as we continue to uncover the latest in technology and telecommunications. See you in our next session.